Inductors are fascinating components that play a crucial role in many electronic circuits. Let's dive deeper into their workings. Inductors operate based on the fundamental principles of electromagnetism. They are essentially coils of wire that store energy in a magnetic field when electrical current passes through them. When an electric current flows through a wire, it generates a magnetic field around the wire. This is a basic principle of electromagnetism discovered by Hans Christian Ørsted in the 19th century. This magnetic field is invisible but plays a crucial role in how inductors function. The strength of this field depends on the amount of current flowing through the wire and the number of turns in the coil. Now here's where things get really interesting. The relationship between the current and the magnetic field is dynamic and constantly changing. When the current flowing through the inductor changes, the magnetic field around it also changes. This change in the magnetic field can induce a voltage in the wire, a phenomenon known as electromagnetic induction. This change in the magnetic field induces a voltage across the inductor, opposing the change in current. This is described by Lenz's law, which states that the direction of the induced voltage will oppose the change in current that created it. Think of it like this. Imagine you're pushing a heavy shopping cart. The cart represents the current, and your effort to push it represents the voltage. When you suddenly try to stop, the cart resists the change in motion and wants to keep going. This resistance to change is similar to how an inductor resists changes in current flow. Similarly, an inductor resists changes in current flow by inducing a voltage that opposes the change. This property is what makes inductors so useful in filtering and tuning applications in electronic circuits. This property of inductors, known as inductance, is what makes them so valuable in electronics. Inductance is measured in henries, named after the American scientist Joseph Henry, who discovered electromagnetic induction independently of Michael Faraday.